I'm James Johnston, Manager of Training and Support at MicroSurvey Software. In this short video, I'd like to give you a bit of an overview of the capabilities of MicroSurvey when you're working with digital terrain modeling. I have a few examples open here that'll give you an overview. In this one, I'd like to demonstrate how we can create surfaces from 3D drawing entities and points from the points database. And so in this case, this was a survey of a hole 16 at a golf course. And so we've got lots of points, and as you can see around the perimeter here, we've got lots of break lines. And so the process of creating a surface, you just use the extract a surface function here. It'll prompt you for a name for your surface, and then you window in what you need. It's that simple. And then all I've done here is I've just plotted a tin to kind of visualize the surface. And so that's sort of the first step of creating a surface and making it into something useful. And then what I'll do is I'll freeze that tin just so that I can show you some of the things that we created from it. In this case, let's go back to the top view. And I can zoom in here, and I will use the isolate tool so that we can just focus in on the contours that have been created. So we plotted some contours, in this case at a half-meter interval, and we also smoothed them so that they're not quite as jagged as you see when you plot contours directly on the tin. And I can zoom in here as well. And so you notice how we used an option to alternately color. In this case, it was every fifth contour. And I've also gone in and I've added a few elevation labels at one end and at the other end. So that's how we can create a surface and create contours. And now our modeling system will allow you to, once you've created a surface, of course you can save the contours and the tin in your drawing, but those that have to be sort of reused to extract a surface. But what we'll typically do is, once you've created a surface, we save it as a binary file called QSB, which is very compact and also very efficient because you can trade pure surface information between different jobs, or if you're doing something like monitoring, monthly project, then you can actually use those surfaces to compare from one month to the next. And you can also export surfaces in the LandXML format if you need to send them to field equipment for staking or to machine control for building. Okay, on to volumetrics. Another very common task that surveyors need to do is compute volumes from survey data. Here's an example of a simple stockpile volume, and all that we've done here in this example is I'm using a tin again to represent the surface that we created from the top part of a stockpile, and then down below you can see this green polyline, and that's a 3D poly that can be used to create the bottom, or represent the original ground of this stockpile. And then if I wanted to generate a volume report, I can do a quick little demonstration of that. I would be using, in this case, the surface volume method, which is the most common. I'll activate surface volume, and I've already loaded up those two surfaces, and the usual convention is to subtract new from old. And you'll notice how you've got other options, but in this case I'm just subtracting the old, which is the green polyline, and the new, which is the top, and just pick on OK. Down here in the command line, there is my volumetrics report. So that is the most common, the surface volume method. I'll show you another example here where sometimes you need to do this, and this is a more complex option, and this is where you use the area volume method. So in this little example, I want you to visualize where a problem that you want to solve is you have two surfaces. Again, they might be new and old, and these ones are very easy to visualize. So you'd like to get a volume between those surfaces, but a further complication, of course, is that you want to be able to limit that volume to inside this 2D polyline. And that's easy enough to do. That's using the slightly more complex area method. And so just to help you to visualize it, what I'll do is I'll add a bit of thickness to this polyline just to make it project through. And if we give it a realistic view, then it's much easier to visualize the volume that you're going to get from what I'm about to show you, where this line projects through the two surfaces and your volume would be what's contained inside of this big green interesting feature. So if I were to compute an area volume, and I'll just do kind of a partial demonstration of it, let me take that thickness away. It's back to being that polyline, and we'll switch to 2D wireframe, and I'll go to a top-down view. Sorry, I want to go to View, and then I'm going to go to Area Volume. And so same process that you saw before, where I chose a top and a bottom surface, and I'll just pick the two at random here. And then when I pick on OK, the last thing, this won't work, but you notice how it prompts me to select an entity, and that's where I would select that polyline to tell it to limit the volume result to within the polyline. But I will now escape because I don't have the data loaded up for that. So just remember the area volume. Between the surface volume method and the area volume method, MicroSurvey can be used to resolve almost any kind of a volumes problem, as long as you haven't gotten into things like tunnels and overhanging surfaces. Then things get more complicated. And then finally, I'll give you a little bit of an overview of the design capabilities with MicroSurvey. So here's an example where we've actually got a file from our training selection where students are challenged to create a holding tank design using the auto site design feature. This one's really quite slick because what it allows you to do is represent a new surface that you want to create by adding some 3D polylines, and then it'll calculate your slopes and it'll create a new object. So what students worked through here was they made a surface using these contours, and then here we've got a design of what the tank, what we want it to look like. We want it to be a little bit above the ground. We're going to use the 3D poly, or the 3D offset function, to create the walkway at the top of my holding tank, and then we can use a 6 foot by 6 foot offset to create another polyline that represents the bottom part of the holding tank. And then, as you'll see over here, the students have done all of those things, and they've also just connected those corners as well. So at this point, you've got some 3D polylines that you can see represent the new surface that we want to create. And then what students do is they launch the auto site design dialog, and I won't show you the whole thing, but all that they're doing is they're letting it create one-to-one slopes for cut and for fill, and they're just checking on this include nested polylines. And again, I'll cancel it. And all they did after that was they picked this outside line, it looked inside and collected all the other lines, and then it created a surface. And I'll just turn on the tin to help you visualize what has been created. So there's the new design surface. It was added to that existing ground surface that was created from the contours. And as I zoom in here, you can see how you've got the walkway at the top, and if I back up here and I spin around, we can look at the bottom. We can actually see where the holding tank gets inserted into the ground as well. So there you go. So that's something else that you can do with the auto site design. And then I usually use this as a good training example, because you've got capabilities to create new design surfaces from road alignment information. So I'll just talk about that. You can design an alignment, so the horizontal alignment with stations and offsets using this module. You can design a vertical alignment. You can input vertical curvature and so forth, and match it up to the horizontal alignment using the stationing values. And you can design a template, and then you can essentially run that template down your alignment and create a new design surface using a little bit more of a complex routine than we did for this auto site design. And this is very useful, and you've also got capabilities for labeling the alignment. You can export the alignment in LandXML format for field staking, and you can generate volumetrics reports from those design alignments. And I think I've said enough. I think I've covered most of the capabilities that you have with the product. So there you go. There's kind of an overview of MicroSurvey CAD's DTM capabilities. I know that this is just a little bit of an overview, but if you see something that piques your interest, please talk to your MicroSurvey contact and learn some more about it. Thanks for your attention.